gentlemen, Yoav and Erik, it is a true pleasure to be here with you today.
The pleasure is totally mine.
Great to see you both.
Wonderful. Let's get this started. I want to get into, Yoav, some of your foundational work. I want to talk about where the economy is today. I want to talk about where we're headed. But first, you guys came to this issue, AI, game theory, agents, the economy, from different directions. You've met, you've overlapped. Tell me a little bit about how you two met and how you became friends.
You want to start, Yoav?
Yeah, start with Yoav.
It'll be interesting to see if our stories match. So I think I first met Erik when he was then at MIT and he was visiting Stanford. And so I'm a computer scientist, an old AI guy, but I got interested in economics and game theory. And I had a pet theory about probabilities, utilities, and I was just itching to speak with people in this area. And I knew my friends at Econ and GSB at Stanford. But then Erik was so generous with his time and taught me about something called revealed preference theory that turned out to be closely related. And I think that was the first time we actually met. Isn't that right, Erik?
Yeah, I think that sounds right. I think I'd heard about you before, but when I came to Stanford, came from a sabbatical, a nice little thing that you get to do when you're a professor every 7 years. So I came for my first sabbatical to Stanford, had a great time. I'd always been working in CS and economics. I had to focus more on economics just because it's hard to find people who were willing to do both. But Yoav was one of those people. And actually, I remember shortly after we met, then you went off on your own sabbatical and you started it was the height of the internet boom, and you started a B2B internet company and came back a year or two later, having sold it for a few $100 million. And I remember thinking, that's a pretty good sabbatical.
It's a very productive way to spend a year.
But then fast forward a little bit, we met, you worked with Google in various capacities as an advisor, and I later sold another company to Google and we met there. And then we started the AI Index together. That's, I think, really when we really worked together a little more closely than we had before.
Then we got to work on a project together. That was great. I think we were each noticing that there's all this chaos about people making all these claims about what AI was doing, and some of them were true and some of them were hype and nonsense. And I just needed a place to go to that was reliable. And since none existed, I thought we should try to create one. And then you were already ahead of the game doing that. And so we decided to join forces, and you really took the initiative to bring a bunch of people together and get some funding for that. And I'm really happy with the way that turned out.
Oh, it's great, Erik. And you've solved the problem. There is no more hyper nonsense in AI anymore. So you guys formed the AI Index, but I want to talk about that and I want to learn more about how you did that. But before we do that, Yoav, take us back maybe a decade, 15 years before then. Tell us a little bit, just give us a quick synopsis of your foundational work in AI agents, and in particular, the logic under which you thought agents would work that is most applicable to what's happening with agents today.
I'll try to compress it, and it's not compressing 10 or 15 years, it's compressing 30. There's a paper I published in 1993, which became my most highly cited paper. And oddly, 2 years ago, there's a prize for old people. It's called the Test of Time Award. And so it was called agent-oriented programming. And I felt that this abstraction of agents carried force. It's like an object in object-oriented programming, but it had more structure. You had an agent that had, agency. It has beliefs, it has capabilities, it took action, it modeled other agents. So I thought that was a good way to think about AI. And so that was back then. If you fast forward to today, my colleagues, Stuart Russell and Peter Norvig, wrote this best-selling book, The Intro to AI, and it's all based on this notion of agents, increasingly more complicated agents. The truth is today, when everybody speaks about agents, the term has lost its meaning. And I think it's a good idea not to become anal and insist on careful definitions, but to make sure there's actually information conveyed by the term agent. People today engage in what I call agent washing. Anything that's remotely automation of something is now an agent. That's going to come back to bite us.
Yeah, I wish people would be more strict and go back to your definition, or just any definition. And I don't know if it's anal or not, but there's so much, back to chaos of people talking about agents in all sorts of different contexts, from doing very small things, a little action that happens when you click on a item, to very complicated multi-step processes. And they put it all into this category of agent-oriented activity.
Yoav, your solution for today is to come up with a stricter definition of agents, or is it to just let loose the whole stricter definition?
To be honest, maybe it's a coward's cop out, but to avoid definitions. I wear mostly my hat as a co-founder of AI 21 Labs, and we tend to not use the term so much. We speak about complicated workflows in the enterprise that, like Erik said, are multi-step, multi-tool, multi-LLM. We speak about the need to guide them, to control them, to explain them, and some people call those agents, and that's fine. But really speak about more the subject matter than the high-level moniker of it.
Let me ask you a more general question about AI. As someone who's been working in the field so long, how surprised were you with or how surprised have you been with the rate of change in the last 4 years, with the launch of suddenly ChatGPT and now hundreds of billions of dollars going into it?
I think it'd be disingenuous for any of us to say we weren't surprised by how much just brute force statistics with infinite amount of data and compute can accomplish. So yes, I have been, but I've also been very skeptical that will get us all the way there. Deliberately not using the AGI term because it's another term I think means little, but I do believe that intelligence, the way we think about it, will not be arrived at purely by these statistics. And so while I've been taken aback by how much you can get away with, it's become increasingly clear to everybody, I think, that you need to go what's sometimes called the neuro-symbolic route. Even when you call ChatGPT now, behind the scenes, some of it is chasing tokens down, and some of it is calling a package that does arithmetic or calls the web. And I think, in fact, you see now with the release of GPT-5 that the pure brute force approach is plateauing. So I've been surprised by the power and not surprised that it will reaching diminishing returns.
This is 100% want to stay on this for a second. Let me just ask Erik the same question. You clearly saw the power of AI pretty early. You started the AI index well before everybody was into AI. How surprised have you been by the rate of change?
I'm more of a connoisseur than a contributor to this field. And so I've one of the reasons I came out to Stanford is it's been so easy to talk to lots of people. A little while back, Demis Hassabis came by Stanford and we had a dinner conversation about this. And I don't think he'll mind me sharing that, much as Yoav was saying, he said he was quite surprised at how well LLMs were working. He was considering a number of different paths that they were pursuing, and this approach with the transformers just worked much better than he thinks anybody really expected. I mean, maybe there's a few exceptions. At the same time, what we are seeing now, as you have also said, is people building the scaffolding around them and using the tools. LLMs are not really designed to do arithmetic or other things that we have other tools that can do that. And by combining them with more symbolic approaches, you're able to take advantage of 70 years of computer science that have done a lot of advances in those areas. And the combination is likely to get us a lot further. I don't know whether get us all the way to AGI, but certainly systems that are, from my perspective, extremely important in the economy, impactful, boosting productivity, able to do many or most of the tasks, at least the cognitive tasks that humans are able to do.
That is a wonderful answer. I also like the idea that at Stanford, you not only get to meet people like Demis, but all the people who found the next companies, take your classes and drop out of them.
Yes, I had that experience. When I met Yoav, I actually was at Stanford Business School for 2 years. I picked the two best students from my 1997 class to TA for my 1998 class. And a week before classes, they called me up and said, "Oh, Professor Brynjolfsson, we're really sorry. Some guys on Sand Hill Road just gave us $5 million. We're dropping out of school." And I couldn't really blame them. I said, "You know what? Go for it. I'm sure you'll learn a lot."
Yeah, unquestionably a good experience.
That was the internet boom. I think this one's even bigger, though. The data say it's even bigger.
That was an amazing moment. I worked for a Linux hardware company out of Stanford back during that boom, one which did not go public. Yoav, let's stick on this neurosymbolic question because I think it's one of the most interesting questions in AI. Yoav, let me ask you about this really important question on neurosymbolic AI, because of course there's been a debate 30 years between scaling. You've read the bitter lesson, you've heard the joke, every time I fire a linguist, my model gets better. There are many people, Dario, for example, at Anthropic, who seem fully convinced that really just scale. It's what has always worked. Why is now the moment where you believe neurosymbolic architectures are more important than just continuing to scale?
I've got an economist here, so let's appeal to data. If you look at the enterprise, I can tell you back 3 years ago at AI 21 Labs, we couldn't get enterprise to care about stuff. And now there's not a CEO in the world that's not saying I'm an AI first company or I want to become one. And you have companies, we see companies, and Erik can probably speak to this even more, with hundreds of use cases and a whole bunch of prototypes they're trying out. The drop from the prototype or the POC to deployment is precipitous. There are many studies show that. There's an AWS study from a year ago that pegged the ratio of sort of 6% of the projects. There are a variety of reasons for that. And some of them are, I'll say, standard. New technology, need to understand it, understand where use cases. Now, as you touched, lots of people in data, issues of privacy and compliance and security and all of that. And that's all good and relevant. But I think with AI, there are two new things that loom the largest. One is cost. The unit economics of LLMs are different from unit economics of traditional software. And so, especially if you look at the LLMs, not the SLMs, the small language models. So that's one thing that's giving people pause. But the bigger thing is reliability, reproducibility, controllability, explainability. And I like to say that in the enterprise, if you're brilliant 95% of the time, and 5% of the time you're not just wrong, but it's ridiculous, then in some cases it doesn't hugely matter. In other cases, you're dead in the water. And so that's why people are very skittish about actually deploying these. With agents, again, to use the A word, things are less transactional. Single call to an LLM and get back just some text back. But you've got an ongoing interaction with many steps, using many LLM calls, different LLMs, multiple tools. This AI system can be proactive, not just react to you. And it can do things more than just give you text back. It actually take action, call a change a database, make a call, sends email on behalf. There, the issue of reliability just explodes because, as we know, got a little error, maybe 90% error, but now you cascade it 100 times fold, you get more noise and signal. And so I think that's the biggest thing, and that's the reason that just I like to call it prompt and pray. Prompt and pray is not a durable strategy in enterprise anymore.
But let me just ask one quick follow-up. Why won't scaling solve prompt and pray? Scaling has led to a decrease in hallucinations. Why can't it bring it to zero?
One can argue whether it actually reduces hallucinations. Measuring it is very complicated. I don't know that GPT-5 hallucinates less than GPT-4, but it is and will always be a probabilistic system. Unless you put it inside an AI system that does not just probabilistic validation, but deterministic validation as when it can, and gives you the error bounds, until you control it and put it inside, it'll just be a probabilistic system. And as you get more ambitious and cascade more and more, the error probability will mount. That's just the nature of probabilities.
Erik, is Yoav right in diagnosing why enterprises have not adapted AI as quickly as some enthusiasts predicted they would?
I agree with his diagnosis. Let me just to underscore the last point, especially with these agentic systems where you have multiple different steps. And if you have a probability of making a mistake in the first step, and then there's a series of them sequentially, then that's going to just compound over time if they all have to be correct. And in many processes, that is important. As an economist, though, I want to emphasize that it's amazing what the computer scientists have done to improve the reliability of the systems, somewhat less hallucination, putting scaffolding around them, other kinds of techniques. There's something else that I want to bring to the game, though, which is bringing in humans. And one of my frustrations is that in the enterprise and everywhere else, people too often look to try to automate an entire process or just remove a person from something and replace it with a machine. And almost all of our benchmarks, like in the AI index, when we gather the different benchmarks, they are based on having a machine, how well it can perform by itself. Can it read this radiological image? Now, when you go and then put it in a hospital, what you find is that the doctors don't find that nearly as useful. It says, oh, you need to cut off the patient's left leg. And the doctor says, well, why? And says, well, probability 0.9. And maybe a better one says probability 0.92. That's just not that useful. You have to be able to explain what you're doing. And humans and machines have complementary and different strengths and weaknesses. And most often, the two of them together, the two types of entities, can do better than one of them alone. And one of my pieces of advice to the enterprise is when you implement these systems, look for ways of having it work alongside humans. And that will mitigate some of the problems that Yoav pointed out about these systems not being perfect. We worked with a call center, for instance. I was just talking to some of them yesterday, and they still had humans in the loop and make the ultimate call, and especially for some of the more difficult questions. And that was a way of addressing some of the concerns about hallucinations and error bounds. Of course, humans make mistakes too, but we make different mistakes, and you have to have an overall system that's as robust as possible.
Couldn't you actually be contradicting Yoav's point in an interesting way, right? So if the argument is scaling law has been super efficient, it's worked really well, but we need symbolic architecture to make sure it doesn't make mistakes, to make sure agentics, particularly in multi-step processes, don't make compounding mistakes. Couldn't you just say, really the solution is super fast scaling law systems with humans in the loop so they can bring it back to reality when it spins off in a strange direction? Wouldn't that be easier than trying to reconstruct these large language models on a new architecture?
Well, it's not an either or. I agree with Yoav's diagnosis, and I think the computer scientists should keep computer sciencing and make their systems better and better. I think that managers and economists should look at how the total system can work, and often that means bringing in humans. There are places where you can have a standalone system, and that's great. But it's just, I think we all tend to underestimate how hard that is. I first drove in a Google self-driving car in 2012, believe it or not, from Mountain View up to San Francisco on Route 101. There's photos of me, I'm not making this up, with Andy McAfee, and we were very excited. We wrote about it in our book, Second Machine Age. I thought, okay, we're practically there. There's a little fine tuning around the edges. It turns out that last 1%, that last 0.1% is incredibly hard. That's a microcosm for what seems to happen over and over in lots of different areas. You have this part of the problem that it can be well-defined, specified, and AI can just crush that, especially if you have lots of data for it. But then there are these edge cases that just don't appear. And machine learning, of course, learns from data. And if there isn't data, it's very hard for it to come up with the generalizations for solving that. I wouldn't say that humans are great at that either, but we've somehow muddled through most of the time. So this is something that I've come to appreciate more. And when I talk to managers, I do say, look, it's great to keep improving the reliability of systems. And for certain areas, you really need to do that. But don't count off the humans for being able to have an overall process that works pretty effectively in most cases. And
do you agree?
And back to the benchmarks, by the way, this is something I should talk to Yoav about as well. We haven't yet. I'd love to see more, we call them centaur benchmarks, that are designed explicitly to have humans and machines work together. When Gary Kasparov lost to Deep Blue, one of the things he did was he created a set of contests where humans and machines could work together to beat other humans and machines. They could beat Deep Blue, at least for a while. And I think there are many activities still now where we could benefit from having benchmarks that steer the research enterprise towards having humans and machines work together.
Yoav, do you agree with Erik's diagnosis of where this is going, or do you think that we're at a temporary moment where we need humans and machines, and actually, with proper future architecture, we can build machines that can fully do tasks and allow us to move to higher order processes?
I would love to disagree with Erik. He'll make for such a fun dialogue. I actually agree with him. And I'm glad he spotlighted this issue because, and he's right, this is not either or. We want to increase the scope in which these AI systems are reliable, controllable, explainable. But that scope will always be partial. Even in our orchestration system called Maestro, where you orchestrate lots of calls to different parts of different LLMs and everything, there's always a role for the human where the human can intervene proactively and say, I have a say here. You got a plan, do something. I think it's the wrong plan. Or the system itself saying, I've planned it partially, and here I don't think I have enough information, enough insight. I want help. So we very much believe in, we call it sometimes the cyborg organization, where it'll very much be a cyborg organization with human and machines working side by side and appropriate division of labor. And by the way, I think we will learn in time what parts we feel comfortable really delegating to a machine and which parts we still want to keep an eye on. I think it'll be an evolution.
Look, Yoav, if you're not going to disagree with me, then I will disagree with me a little bit, or at least on Nick's characterization. And when you said the word always, that sort of made, whenever I hear that word, as a researcher, I'm always like, okay, let me see if I can think of a counterexample. I do think that we are in some ways potentially in a temporary period. It could be a very long, decades long or more period. Ultimately, chess did fall to the point where humans don't add much. If a human tries to give advice to AlphaZero, I think they would find it just like an annoying gnat and say, please, I'm thinking here. And likewise, while I said we can't drive from Mountain View to San Francisco, we can drive around San Francisco. And I don't doubt, in fact, we should probably check my Waymo app today and see if they've already added the capability. So these capabilities are evolving. And I think there will be, especially in well-defined narrow areas, more and more where we will be able to delegate. I see it as in our call center paper, we had a kind of a power law, long tail, if you can see my arm here, where there's some very common questions, like how do I fix my password? And there are very obscure questions. And the AI did pretty well on the common and in the middle questions and working its way down the tail. That's my metaphor for a lot of different activities. And I don't know how long that tail is. Does it go out for infinity or a very long time? For some tasks, I'm sure it is going to be a very long time before machines can do it. But I'm not sure I'd ever say never.
I remember a study, and I think you tweeted it out. It was 2 years ago. It was a study on doctors, and it was basically had 3 categories, and it was like doctors with AI on its own. And the top performer was AI on its own. The second performer was doctors on their own, and the worst was doctors with AI. And it just seemed like for some reason the doctors were accepting the wrong answers from AI and rejecting the correct ones. Obviously, there have been like a whole series of other studies on this very same question. Are we learning how to properly work with machines, or is that still a social struggle for us?
It's definitely a social struggle. And there was a more recent study that found a similar result with coders, where the coders thought they were doing better when they used the tools, but actually, if you measure them, it was taking them longer. Apparently, they would give a task to the vibe coding system, and then they would go off and watch a YouTube video, and they would just keep watching the YouTube video even after the vibe coder finished. And in the end, they ended up spending more time goofing off. I think that we do have to learn how to use the new systems. Most of us have been led astray by social media at various times where it just ends up not doing what we really want. Most of us have this conflict between, I call it system 1 and system 2, and like Dan Kahneman and Tversky described it, where we don't always do things in as structured a way as possible. And when new technologies come along, we have to learn how to take advantage of their strengths and avoid the pitfalls. I see that happening over and over. Part of it I attribute to bad user interface, bad design, bad training. But I also think that ultimately over time, successful organizations, successful people learn how to use the best of them. And it's just that it takes a lot longer than most of us anticipated initially. And this is a recurring story in history where there'll be an amazing technology, the steam engine, electricity, automobiles. And at first, it actually hurts productivity and performance on lots of different dimensions. But sometimes, literally decades later, the second part of what we call the J curve, where it takes off. I think we're still in the early stages for most types of AI systems. Some of them are having that payoff, but it's not something that's going to happen in the next couple of years the way a lot of my Silicon Valley friends are predicting.
Do you think it's actually, this question for both of you, it seems like progress is slowing down, right? GPT-5, not that much better than GPT-4. The rate of change is certainly slowing. Is that actually a good thing for economic adoption? Because it's very hard to integrate a fast-moving process into your workflow. It's very hard for an organization to add a tool that's going to be twice as good next year.
I don't know if it's slowing down. I'll leave that to Yoav. I've heard conflicting arguments, but I would say that suppose it completely froze, it just stopped, and all of our computer science people decided to take some time off. I think there would be easily a couple of decades of work for economists and business people to take advantage of what's already been invented and integrated, and productivity would start taking off just from the stuff that's already in the can. So yeah, we do need some time to absorb it. And maybe paradoxically, I'll push this a little bit, that yeah, if there were a little bit of a pause, we could say, okay, now we know what we need to focus on. The fact that it's constantly changing, there is actually an economic incentive to wait a little bit. When technology is changing very rapidly, it is actually optimal to wait a little bit more than you would if technology was static, because you know that it's going to get cheaper, better, faster in a few months or years. And that gives you less incentive to invest today.
Yoav, do you think the rate of change is slowing down?
First of all, I'm afraid I can't give Erik the comfort he's looking at. We're not going to slow down, so sorry about that.
Please, we can't keep up.
By the way, we can't keep up. If it weren't for all these people half my age that read every new thing that comes on GitHub or on archive, I wouldn't have a clue. I think, though, what you see now, especially the enterprise, is maturation. It's not necessarily that the most recent tweak on Transformer or the next model or the next benchmark that came out, that's becoming a little bit, that I think is plateauing. What's happening in the enterprise, without exception, what we see is that if you can think of it as a two-dimensional kind of space. On the x-axis, you have automation, LLM, do your magic. And on the y-axis, you have reliability, controllability. Initially, AI was all in the bottom, automation, LLM, do your magic. And as you try to do real stuff, not just a demo, you try to do things like React and frameworks that will try to self-optimize. We don't see any of that working in the enterprise. What we're seeing is, since they have to do AI, they're building AI systems the old-fashioned way. They have typically hundreds of people building a complicated system, except now there's a new toy to put in there. It's called an LLM. So how to use that, how to control, you use it, what it's good for. And so they're doing a bunch of one-offs, reinventing wheels there. And what you really want to be is towards the upper right, where you have automation, AI doing its magic, but in a reliable, controllable, understandable way. So it's less of a fancy demo moment. Oh, look, my system can get gold medal in the Math Olympiad, which, by the way, great achievement, but that's not what will get you in business in the enterprise. And so what you're seeing is more system building that understands modern day AI and crafting solutions for the enterprise. So I think there's progress there, but it's less perhaps sexy.
And I remember some advice that I heard recently that struck me as apt, and I'm curious if you think this is right. It was advice to startup founders, and the advice was, you have to be building right at the edge of capabilities, right? If AI can do the thing right now that you're trying to do, you're already cooked. So you have to find the thing that it's close to being able to do. Is that good advice?
I need to think about this one. I think, first of all, I don't think I've had the pleasure of starting several companies, and I think everybody plays to their own strength, and there are different ways to succeed. There are also different ways to fail. But so I think definitely if you do something that's already solved, then, that's not a good idea. Whether you want to get to the edge of technology or to edge of where a problem that cries for solving hasn't made contact with the existing technology, I would actually tend to advise the latter.
I think it's one thing if you're a tech startup trying to invent the future, but for the typical enterprise customer, I don't think you need to be quite on that bleeding edge. There's so much low-hanging fruit of stuff that's been invented but not yet implemented. There's no shortage of massive gains from that. I think it's frustrating that too many big companies are not really taking advantage of those easy wins, and instead they're having these hackathons where people play around with LLMs for making, a lunch menu for their team or something, and that's not really adding much value, maybe creative and fun. It's time to really connect it to business value. Look at what you're doing in coding and software development. Look at what you're doing in your call center, in your sales operation, and lots of other places where there are millions, billions of dollars at stake in some companies, and there are some proven opportunities to apply AI in those areas. Along with Tom Mitchell, who used to do machine learning at Carnegie Mellon, I wrote a paper about this task-based approach where we went through and basically broke an organization down into occupations, and then the occupations, each of them we thought of as a bundle of individual tasks. When you get down to this very sort of atomic unit, it's actually very easy, or much easier, to assess whether a particular task can be helped by an LLM or any other technology. And if you do it that way and then look at, okay, is this a task important to our bottom line? Is this something that creates a lot of value for our customers? Now you start having a very data-driven approach to matching these existing solutions to real problems that you need. And putting those two together, I think, is a formula for shorting the J curve and getting us a lot more value a lot more quickly.
I can jump in. I'm really happy because I found an opportunity to disagree with Erik. Not real disagreement, but a little bit. So first of all, Erik, by the way, I didn't realize that you and Tom collaborated on this task-based breakdown. It was probably an outcome of the committee you chaired at the National Academies on AI and the.
It went the other way around. We did that paper, and then we decided to chair a couple of committees for the National Academies. But yeah, it was
very cool.
Really the start of our collaboration.
Very cool. That's another amazing collaboration between a top economist and a top AI person. But so I think that's great, and I agree. I think this is the right way to look at the tasks rather than job descriptions. The part where at least my experience diverges a little bit from Erik's description is that I actually do see in the enterprise a maturation and focus on high value. The typical engagement we do at AI21, we don't work with lots of customers, typically the very large ones, and we'll say, okay, let's look at all the use cases. Let's find one that really important to you, not nice to have, but key, where we believe technology risk is pretty low. And let's go nail this one. And for example, it does not abstract. We've worked with a large, I think we can mention the name Fnac in France. They have a very big e-commerce kind of business, like thousands, I think millions of items come online all the time. And doing product descriptions is labor intensive, costly, time consuming. And so you want to do product description in a way that's consistent and reliable. You don't just take an LLM and hook it to a RAG and you get the solution. But if you think about the problem and do the right kind of AI system flow around it, you get the reliability where now they're doing it at scale. It's really, and we have other use cases where, at least from our experience, whether it's this CIO or the CAIO is the adult in the room that's pulling it in a direction that's actually meaningful to the company.
Erik, you want to respond to the disagreement?
I'm not sure I totally saw the disagreement, but I think I agree with most of what Yoav just
said.
I tried. But there are these lots of opportunities there. I think being not just from the technology forward, but as Yoav was just describing, looking at the tasks and opportunities and going and seeing which technologies can help with those is a big part of the solution. Overall, I don't think companies are getting nearly the value that they could be getting. I think there's a disconnect between these eye-popping benchmarks, winning the gold medal in the Math Olympiad or whatever, that are just like almost superhuman, and I'm in awe of them. And then when I go to companies, I see that productivity in many of them is not improving. Sometimes they have these disappointing results. You mentioned in the medical example, companies are not always happy that the chief AI officer is often under some heat for not delivering as much value as the hype might have suggested. I think it's a totally solvable problem. And in a way, I'm glad that we have this opportunity to close that gap. My own company, WorkHelix, works with a lot of companies to focus on that, to identify those opportunities. And I'm fairly confident in the next few years, we'll start seeing some much bigger gains showing up, not just at the business level, but at the whole economy level, official productivity statistics. I think the Congressional Budget Office is actually underestimating the likely productivity gains, barring some craziness that are outside the scope of AI. But based on just the technology that exists, I think we're going to have business transformation speeding up. It's going to happen as fast or faster as what we saw in the 1990s, where there was a nice roughly doubling of the rate of productivity growth from about 1.5% to over 3%. I think we could easily see something similar in the next few years in the United States.
Wait, Erik, I have to disagree with you on something, which is the gains that we've realized, because I read this really interesting op-ed in the Wall Street Journal the other day, and it was making the case that AI has actually been far more beneficial in the short run than most people think. In fact, it said the value is something like
$97 billion. You want to get wonky about this. Okay, so I know the op-ed that you're referring to. I know the guys who worked on that. I think you're referring to the paper that Avi Kallas and I did, where we did show there are significant gains in consumer surplus, but not in productivity. And one of the things that squares the circle there is that consumer surplus, which is basically how much benefit a consumer gets minus what they're paying, is a different number than the GDP or productivity numbers, which reflect what people are actually paying for. So in the case of AI, in 2024, it was about $8 billion that the LLM companies were collecting, closer to $100 billion of consumer surplus. So that's great. And so there is definitely some big gains there. A lot of us are getting these tools for free. Over time, I think that will translate into measured productivity as well. That is dollars going to the enterprise, going to the AI companies, and we'll start seeing that transition happening as well.
Erik, explain how you measure that consumer surplus, because it's when I read the op-ed, I found it utterly fascinating how you came up with that number.
Yeah, the basic idea of consumer surplus is this concept from Economics 101. It's the difference between the most you would be willing to pay for something. So like for this shirt, if I would have been willing to pay, I don't know, $150 because I really like it, but I only had to pay $100, I'm getting $50 of consumer surplus on that shirt. And same thing with my shoes. Now, there are a lot of things that are free, Wikipedia. And so the average person, according to our surveys, is willing to pay $20 to $30 a month for access to Wikipedia, the average Wikipedia user. They have to pay $0. So there's a huge amount of consumer surplus compared to what they're getting. The problem is that in the US economy, I don't know if it's a problem, but the challenge is that more and more of what we're getting is digital. The average American spends about 8 hours a day looking at screens like you and I are right now, sometimes little screens, sometimes big screens. Most of that digital information has zero price. And in our GDP statistics, with few exceptions, if something has zero price, it has zero weight in GDP, and productivity is just defined as GDP divided by hours worked. So if it's not in GDP, it's not in productivity. Now you can see we're missing out on a big part of the digital revolution, a big part of the AI revolution, if we're only looking at GDP and productivity. And that's why we create this new metric based on consumer surplus. We call it GDP-B, which aggregates how much of a change there is in all of those areas. And what we're seeing is that there's been, as you can imagine, an explosion of value in digital and AI goods that's not accounted for. Ultimately, our goal, we have a project here at Stanford, is to create a parallel set of numbers based on GDP-B, the consumer surplus, that we can publish alongside the official GDP numbers. And now we can see not just what we're paying for stuff, but also how much value we're getting. This is, I think, for the 21st century, I think we're going to have to rely more and more on these new kinds of metrics, not just the ones GDP was invented back in the 1930s.
Nick, can I ask a follow-up question to Erik, a person ignorant of these matters? Is the fact that GDP is not rising nearly as fast as consumer surplus, does that mean that the digital goods are being underpriced?
Not necessarily. It's actually the nature of a well-functioning economic system is that if there's competition, that benefit gets swept to consumers. Bill Nordhaus, who got the Nobel Prize some years ago, estimated that about 95% of the gains from innovations over the past century have gone to consumers, not to the inventors. And that's perfectly healthy. That's what Adam Smith would have wanted. Adam Smith, when he described that capitalist system, said ultimately the consumers are benefiting. And what happens is that when there's an innovator, they capture some value, then someone else comes in and competes. The two of them have to lower prices or improve quality, and the consumer wins. So it's a good thing that we're getting consumer surplus. That's what a lot of what's raising our living standards. There may be in some particular areas room for companies to raise prices and capture back some of the consumer surplus. It doesn't always go in one way, but I'd say most economists would consider it a feature, not a bug, that consumers get most of the benefits.
But it's a weird situation where investors and venture capitalists are massively subsidizing these companies, which are then providing a product at a loss that consumers extremely value. And so you can imagine an equilibrium where it settles at a low price because there's competition and there's open source, or you can imagine a real shakeout, right? Where eventually there's one winner with monopoly prices, right? What is likely to happen here?
So there's different reasons why the prices might be low. One may be that you can produce them at very low cost. Another may be that there's somebody outside the buyer and seller that is subsidizing it, like a VC. And we saw that happening with ride sharing services and other places. And then the prices did rise. I think that's something we want to keep an eye on. And I don't think there's enough attention to it lately in antitrust to make sure that people don't raise prices. That said, I think it's not the most common pattern in technological progress. Most of the time, the goods and services just do keep getting cheaper and cheaper. And if you look at the official price indices for a whole set of different technologies, it's relatively rare that someone's able to reverse that. I wouldn't say impossible. And the description you just said of VCs sometimes subsidizing early on and then cashing in later, I think, who was it? Somebody called it enshittification, which is more evocative. This idea that people could seize back some of the value. That does happen. I think if you look at the broader sweep of technology, it's not the main pattern that I see.
I want to ask you about a big question that's related to this, which is one of the weirdest things to me in AI is that in every survey, AI is clearly beneficial, right? I'm much better at my job because of AI than I would be without it. How much better? Hard to measure, but certainly it helps. In every survey that's done, men seem to use it more than women. And you guys have both been in this field forever. I can see the structural biases about why AI companies founded by men are more likely to get funded, but just for use cases, I don't understand that. Do either of you have a hypothesis?
Without getting into deep trouble?
Either or.
I don't, but I'll tell you an anecdote. That's only vaguely related. So I had this freshman seminar at Stanford, which I called "Can Computers Think? Can They Feel?" And I would start I would ask, can computers, can they think, understand, feel, have free will, be conscious? And I'd ask the question at the beginning of class, end of class, and in between we'd speak about what those things mean. And one thing I noticed was that there was definitely a gender discrepancy in the answers, can computers X, where for women, they basically saw distinct differences and guys couldn't tell the difference. It's anecdotal, and I don't know if it directly bears on your question, but it reminded me.
Yeah, I don't have a great hypothesis. How about you, Nick? What do you think?
There's probably some bias, right, for the roles that people go into, right? Men are more likely to become software engineers are more likely to use AI, therefore there's some survey bias. The best hypothesis I've heard, which came from, I interviewed Navrina Singh, who's a friend of mine. She's the founder of Credo AI, and I asked her this question on stage last week, and her answer was essentially, men are more comfortable with BS. And so they're more comfortable with language models as they exist right now. So that's definitely the funniest answer. Whether it's the one with the highest explanatory power, I'm not sure.
Yeah, it's interesting. It is an interesting pattern. Obviously, there's lots of these gender differences, not just among LLM users, but in lots of different areas. And I don't know if they all have a common explanation, but it is a widespread pattern.
Let me ask you another big question, Eric. So you've written about the Turing trap and the notion that the closer these machines get to mimicking human intelligence, the more likely there will be significant job displacement. When I first heard that was a brilliant point, it made me question the whole desire of the field to reach AGI. Like, why should that be the goal? And I'm curious whether you have the same reaction.
It's complicated. So part of it has to do with the definition of AGI, which I find a little frustrating. It's often used as a synonym for human level intelligence. And in that definition, does go against my approach in the Turing trap, where I argue that simply mimicking a human, making a machine that's as similar to a human as possible, as per the Turing test, but may be inspiring to a lot of people, but it's actually, from an economist perspective, about the worst thing you can do. It tends to drive down wages and lead to more concentration of wealth. Another way of using AI is to allow it to do new things that couldn't have been done before, to expand the set. And if I'm pedantic about artificial general intelligence, it means more general than humans. And actually, much as I like to think that we're special, we actually have a fairly narrow kind of intelligence. Chimpanzees have better short-term memory than humans do if you play them against game of concentration. Bats obviously can do echolocation. My calculator can multiply much bigger numbers than I can. Very quickly, I can think of all sorts of kinds of intelligence that vastly exceed the typical human or even the best human on different dimensions. And I think some years from now, it'll become more obvious that human intelligence is amazing, but it's actually just one narrow kind of intelligence. And these other kinds of intelligences often are very valuable. So now going back to AGI, let's try to take the full spectrum. And instead of focusing so much on making machines do what's easy for humans and difficult for machines, buttoning a shirt, walking up the stairs. Let's have machines do what's easy for machines and hard for humans, solving complex optimization problems, scanning through billions of documents. We have very different strengths and weaknesses. And once you think about it that way, the goal of AGI, of general intelligence, if you want to say that, of expanding the set of things we can achieve, raising the ceiling, becomes much more appealing. A story I tell in the Turing Trap paper goes back to one of the oldest mythical engineers, Daedalus, who, according to legend, made robots like this one behind me, but better, that were actually indistinguishable from humans, could walk and talk. That was what the legend said. I don't think it was actually true, but that's what the story says. Suppose he had then said, let's do all the tasks that the ancient Greeks do, and let's mimic all of the work, as a lot of people in Silicon Valley are going to looking at each task and saying, how can we make a machine to do it? So if you needed clay pots, the machine would do that. If you wanted a Greek tunic, the machines would do that. If you were sick, the machine would burn incense for you. So everything that the Greeks were doing, the machines would now do. The good news is you wouldn't have to work anymore. Labor would go to zero. By the equation, productivity would go to infinity, zero labor. That all sounds pretty good, and people would have a lot of leisure. But I think you can also see that having rooms piled with clay pots and smoking incense and whatever, it's not really raising our living standards anything close to what we have today. And that highlights this idea that simply mimicking what we're doing today, taking the tasks that we're doing today and trying to just only replicate them, it's beneficial, it's a good start, but a higher ceiling would be to help us focus on doing new things, new inventions, new discovery. And that's one of the directions I'd love to see researchers, economists, business executives focus more on.
Yoav?
Like Erik said, it's complicated. We're good at using terms that are obscure. AGI is one of them. I don't think that intelligence is one thing, and AGI seems like it's a scalar thing. You'll be better and better suddenly you have AGI, you'll get this AGI moment. I just think it's ill-defined. I think intelligence is multifaceted, only we'll get better at certain things and less at others.
Yeah.
I think the Turing test I've never really liked. It was amazing for its time. But Turing test doesn't measure intelligence, not even any particular, it measures humanness. Intelligence is one aspect of human, but many other aspects. And actually the biggest Turing test experiment to my knowledge ever is something that we conducted at the company. There's an app we built called Human or Not, over 10 million people or 10 million people. It's a very gamified Turing test where you had I think we took it down already, but a 2-minute time to interact with either human or bot and decide which one it is. And what our guys did was, in order to try to fool, is to deliberately not answer too quickly, put in spelling mistakes, and use emojis and stuff. And so deliberately, so I just think the Turing test is not a test of intelligence. I think that asking whether we will reach human level intelligence is counterproductive. Machines are much better than us in arithmetic. That's an aspect of intelligence. There are other things they'll be better at, because now they not only have reasoning capabilities, they have amount of knowledge that defines intuition. So certain things they'll be better at for sure. And I agree with Erik. The other thing I'll say is that we don't have the right abstraction, the right language with which to speak about LLMs or AI today. Because we look at an LLM, clearly it's not just a database that memorizes information and spits it out. It does something more. It has to represent that vast information in a lower dimensional space. So somehow it's created internal, so something interesting is happening. And so the inclinations say, oh, then it's not a database, then it's like us. But of course it's not. We don't have the right language in which to speak about what aspects of intelligence are captured in today's AI and will be as we continue to progress.
But Yoav, do you feel like the field of AI has been well served by the focus among the large companies, among the most powerful people, of trying to match human intelligence, even if it's ill-defined and even if we don't really understand it? Like Sam Altman very clearly has said many dozens of times that he thinks that the route for AI is to be as much like human intelligence as possible. DeepMind has followed a kind of a different path. Do you feel like this path that the field has largely chosen has been in some ways the wrong one?
I think it's been a blessing and a curse simultaneously, and I'll explain.
Yeah.
It's been a blessing because there's no argument that statistical prediction at scale is an essential component of intelligence. And by pushing on that, I think that was a huge service to AI and to society. By ignoring the fact that's necessary but not sufficient, that's been a hindrance. And I think now people realize that. And so it's not like people are training larger models, but people realize that even our friend Gary Marcus isn't always wrong.
Gary actually has been taking a victory lap the last couple of days. He feels like he's been vindicated by GPT-5.
Power to him.
Can I ask you a question? We never quite finished the thread on neuro-symbolic AI, and there's a question I wanted to ask about that, which is, I buy your hypothesis, even though I was gently pushing back on it earlier, that we do need some kind of symbolic architecture, or that the world would benefit from some kind of symbolic architecture that would limit hallucinations, improve explainability, solve some of the problems. To get that, can you bolt it on top of what exists today, or do you need to insert it at the beginning and build a new kind of model?
It's complicated, and I think the answers we know the answers only partially, and I think the answers will evolve. I'll tell you what doesn't work. What doesn't work is saying you have an LLM at the outer loop. That's a master of ceremonies. And by the way, if we need to do arithmetic, we'll call a calculator. What you need is something more holistic. What you really need, because at the end of the day, when we have especially complicated problems to solve, complicated tasks to achieve, what we do is we break them down. We describe them in some kind of symbolic way of what it's going to do, what before. There's a reason time is such a central aspect of intelligence, temporal representation. What happened before what? Why causality, ill understood as it is, plays such a central role in our intelligent thinking. And that has to be at the core of what the systems do. But now it needs to live well with the statistics. And there's various ways to meld them. And we can speak about that, but it's not statistic on the outside and, by the way, symbolic reasoning. It's much more explicit, deliberate reasoning that uses statistics.
That makes a lot of sense. I want to ask you a kind of a big question about how young people should think about AI. Yoav, when I last saw you, I was with my son, and I asked you whether he should take linear algebra next year as a way of understanding AI better, or whether he should take multivariate calculus. And you gave a very thoughtful answer. I've asked a number of AI experts how my kids should think about their futures, and I've gotten some good answers. So Jeff Hinton said, there's too much change, you can't really be certain. His first suggestion was that they become plumbers because he thought that would last the longest. His second suggestion was just go with what you're passionate about. I asked Roman Yampowski. He said AI is going to kill us all, so they should just go to party schools, enjoy life while they're still
Oh boy.
What is your advice to young people about how they should think about their choices as they go to a school like Stanford, or as they just go to college and think about the working world?
You want to go first, Yoav? Or you?
Go first.
Sure. It is a rapidly changing technological environment. In the second machine age, Andy McAfee and I described a bunch of skills and capabilities, and some of them are held up: creativity, long-term planning, interpersonal skills, emotional intelligence. All of them are being challenged a bit. I was just talking to Rana Al-Kaloubi about some of the emotion AI systems that are getting very good, arguably better than humans. One, coming back to our agentic world, one that I think may have some lasting power is understanding management and leadership, not just of people, but of now increasingly agents. I think we'll all be in charge, we'll all be the CEOs of a fleet of agents. And they're great at executing tasks. They're not necessarily good at defining what the task needs to be, asking the right questions. And so that's something that a CEO or a smart person needs to do, that front end. Also, in verifying, saying, hey, is this really what we want to have done? And assessing whether or not it was done to the right standards. So if you think of these 3 steps, defining it, executing it, and verifying it, humans are especially good at or valuable for the first and the third steps. And those can be learned. You can train those. And that is a leadership skill for humans and machines. More broadly, I'll give a meta answer, which is, in this rapidly changing world, be adaptable, be ready to learn things. Thinking that you can go and become a plumber or an economist or anything else and just do that for the next 40 years is not realistic. Instead, you have to go in thinking that you're going to be constantly adjusting and being nimble. No company or country or individual is going to succeed by just locking in place and trying to preserve whatever they're doing for as long as possible. On the contrary, we all have to lean into change. And that's where the success is going to come.
My answer, I think, is compatible with Erik's. I think I would start with where he ended, saying that you have to be comfortable with uncertainty and imprecision and thrive in that environment. And you have to have the tools to do it, which part of them are mental and part of them are just technical tools. And that segues into one area. So when you say, what should I focus on, is where would I want to use it? And one place where I think is going to play an increasingly strong role in the world is of the technical product manager. And I'll explain what I mean by that. So in general, product management, it took me a while to understand how central of a role, because it's so ill-defined, or at least, but it's really an interpolation between understanding, internalizing a need of a user, a customer, understanding the available technology, and somehow interpolating between them, making the connection. I think that people, as technology is becoming complicated, sophisticated, and changing rapidly, that impact the role of the product manager. And people speak about product market fit. I speak about product algo fit. I think the meaning that you need to understand what problem you're trying to solve, understand the technology, where it is today, where it's going, leverage what it's good for, and compensate for its current and anticipated shortcomings. I think as an organizing principle, first, I think that's going to be there'll be an increasing demand for that kind of role in the enterprise and generally in the world. And I think the set of skills that feed into that is something that will inform where you should focus. And yeah, that includes linear algebra.
Oh, that's so interesting. So if you're a product manager, it goes back a little bit to that question we were asking about what are the tools you should build if you're a startup, or what are the things you should build if you're in your company's biz dev. But you should really be thinking about where this is going, what the algorithm would do, how you evolve the product, how the user needs will change. In media, AI is going to change the way people read the content, the way we produce the content, and everything in between. And product managers need to be able to anticipate each of those different changes at each different level.
I like those 2 pillars. I see that a lot. If there are people who have technical skills, who understand what the technology can do and where it's going, but also understand the business needs, the customer needs well enough, and can bridge that. That's an area of really high value creation. You see a lot of people who are really strong in one or the other, but when they can do both, that unlocks a lot of value.
Yeah. Okay, great. Any last thoughts you want to end on? You have anything that Erik got wrong that we didn't fully cover?
Lots.
Erik's never wrong. That's the problem.
No, you guys are both wonderful. You both are full of incredible insights. Thank you so much, Erik Brynjolfsson. Thank you so much, Yoav Shoham.
Real pleasure. Always fun to talk to both of you.
Thank you, Nick and Erik. As usual, always a pleasure too. Bye.